Hello, welcome back to another lesson. So we are continuing with probability. This is part 3 that we are going to consider, and we are going to look at a tree diagram. It's a visual tool that can be used to create both the dependent and independent events. So if you can recall, we had discussed about the probability space or the outcome of a particular event. So for the dependent and the dependent events, when we use the tree diagram, it usually gives us the outcome in a very nice way, in a visual way. And we're going to do 4 examples to be able to demonstrate how to use a tree diagram. So we have the first question that we're going to consider. The probability that Joanne goes to Nakuru is a quarter. If she goes to Nakuru, the probability that she will see flamingo is a half. If she does not go to Nakuru, the probability that she will see flamingo is a third. Find the probability that Joanne will, part A, go to Nakuru and sees a flamingo. Part B, not go to Nakuru, yet she will see a flamingo. And part C, she will see a flamingo. So this is an example that you can be able to use a tree diagram to be able to get the possible outcome and be able to answer the question accordingly. So let's dive to it. So the first thing here, we just need to understand the question and be able to come up with the scenario that is being brought about by the question. So we have 2 points here. Joan can either go to Nakuru or not go, and when she goes to Nakuru, she can see the flamingo or not. And even if she does not go to Nakuru, she has a way of seeing the flamingo and also even not seeing the flamingo. So that is the case that we have here. So we are going to do a tree diagram. So the first thing to have is going to Nakuru or not going to Nakuru. So we are going to have a tree diagram there. So can say Nakuru can have at n, not going to Nakuru, we can have n prime. So if she goes to Nakuru, she will see the flamingo, so can have the f for seeing flamingo and f prime for not seeing flamingo. And in the case where she have not gone to Nakuru, still she has the chance of seeing the flamingo or not seeing the flamingo. So we have the 4 outcome here. We have going to Nakuru and then seeing the flamingo, and you have the other second case, not going to Nakuru and not seeing the flamingo. And then case number 3, she does not go to Nakuru but sees the flamingo. And then case number 4, not going to Nakuru and not seeing the flamingo. So in our first case here, we need to have this probability. We have been told that if she goes to Nakuru, probability is a quarter. So going to Nakuru is a quarter. So of course, not going to Nakuru is now 3/4, because the 2 of them should add up to 1. So we are further told that if she goes to Nakuru, the probability that she will see flamingo is a half. So seeing a flamingo is a half, and of course not seeing a flamingo should be a half. Then the other case, we are told that the probability that if she does not go to Nakuru, the probability that she will see a flamingo is a third. Meaning, in our case here, where she does not go to Nakuru, the probability of her seeing a flamingo is a third. Meaning, now if she does not go to Nakuru, the probability of not seeing the flamingo should be 2 out of 3 or 2/3, because the 2 of them should add up to 1. And so that is the possible outcome. And having the tree diagram, it is very easy for us to answer any question that can be asked. So the first question there, we are being asked to get the probability that she goes to Nakuru and sees flamingo. So you're interested with the first outcome there, probability that she goes to Nakuru and sees the flamingo. And in that case, you're going to have, as this is probability of n, of course you multiply by the probability of f, that is going to be n is a quarter, we multiply by a half, and this is going to give us 1 over 8. So that's the probability that she goes to Nakuru and sees a flamingo. Then part B, we are required to get she does not go to Nakuru, yet she will see the flamingo. So not going to Nakuru, and then she will see a flamingo. So that is the outcome number 3. So probability that she does not go to Nakuru, yet she sees the flamingo, will be n prime is 3/4. We multiply by probability of f. Now in the case she does not go to Nakuru is a third, and this is going to be 3 out of 12, and you can simplify that one to get 1 over 4. So that's the probability that she does not go to Nakuru, yet she will see the flamingo. And lastly, we are interested with she sees flamingo. In either case, we have two scenarios. When she goes to Nakuru and sees flamingo, and then when she does not go to Nakuru but still sees the flamingo. So probability that she goes to Nakuru and sees the flamingo, or probability that she does not go to Nakuru, yet she will see the flamingo. So those are two scenarios. So n, probability of go to Nakuru is 1/4. We multiply by f, seeing flamingo, if she goes to Nakuru is a half, or we add n prime is 3/4 not go to Nakuru, then seeing flamingo, if she does not go to Nakuru, we have seen is a third. So we add the 2. So 1/4 times a half, that is an eighth. We add 3/4 times a third. The is going to cancel. You're going to have as 1/4. So when you add the 2, an eighth plus 1/4 is going to give us 3 over 8. So that's the probability that Joan will see a flamingo either through going to the Nakuru or not going to Nakuru. So question number 2. A man playing a game of darts has probability of a third of hitting a double if he throws 3 darts. Find the probability of hitting a 2 double, more than 1 double, and lastly at least a 2 double. So in this case, you're going to use our tree diagram to be able to demonstrate the outcome of a man playing the 3 darts. So in this case, you're going to have the first scenario is that the first dart can be either can hit the double or miss the double, so you can have a D prime there. So the second dart, if the first dart hit the double, the second one, he can hit the double or fail. If he had failed in the first dart, second one, I can have the double or still miss again. And then if he had hit the double in the first case, I can hit the double in the second case. Then third case can be can hit the double or misses. In this case can hit the double or misses. Then this one can have hit the double or miss. The last three can have the double or misses the double. So then we need to know the probability. So hitting the double we have been given is a third. So this is a third, a third, a third. Then missing should be 2/3. So if hitting is a third, then missing should be 2/3, 2/3, 2/3, 2/3, 2/3, 2/3, 2/3. Hitting is a third, a third. So those are the possible outcome. We can have D, 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 can have D, D, D prime, can have D, D prime, D, can have D, D prime, D prime, can have D prime, D, D, can have D prime, D, D prime, then can have D prime, D prime, D, then you can have D prime, D prime, D prime. So now answering the question, we need to have the first one as 2 double. Where do we have 2 double? So 2 double will be in either that case, we have 2 double there, this also we have 2 double there, then we also have this case, we have 2 double. So those are the 3 instances that we have the 2 double. A, we have the 2 doubles as either probability of D, D, D prime, or probability of D, D prime, D, or probability of D prime, D, D. So we're going to be having D, of course, is a third, multiplied by a third, multiplied by D prime is 2/3, plus D is a third, times D prime is 2/3, times D is a third, plus the last one is D prime, that is 2/3, multiplied by D a third, multiplied by D, which is equals to a third. So a third times 2/3, that's going to give us 2/27, plus a third times 2/3 times a third is the same 2/27. The last 3, we have 2/3 times a third times a third, same case 2/27. So 2/27 plus 2/27 plus 2/27 should give us a 6/27. So part B, we are required to get a probability of more than 1 double. So more than 1 double in this case can mean either 2 double or 3 double. So more than 1 double means 2 double or 3 double. So we already have the case of 2 doubles, that case, that, and that. So the other one that we need to add is the case of the 3 double. Probability of more than 1 double is the same as probability of 2 double or 3 double. Now we already have done the probability of 2 double. It will be 2 double, then we add probability of 3 double. So that is D, D, D. So probability of 2 doubles we already have as 6 out of 27. So this is going to be 6 out of 27. Then we add probability of 3 doubles should be a third times a third times a third. And this is going to give us as 6 over 27. Then we add a third times a third times a third is going to be 1 over 27. So when you add 6 over 27 and 1 over 27, we are going to get as 7 out of 27. Then let's answer part C. Part C, we are required to get at least 2 double. At least 2 double means you can either have, the least you can have is 2 doubles. So you can have 2 doubles or 3 doubles. And in this case, the question is just the same as part B, only the wording is different because at least 2 doubles, we need to have either 2 doubles or 3 doubles, 2 or more. Doubles is 6 out of 27, and then 3 doubles is 1 over 27, and then when you add the 2, we are going to have 7 out of 27. So question number 3. We have been told that in a certain town, 15% of the people are bald-headed. So if 4 people are chosen at random, find the probability that 2 are bald-headed, less than 3 are bald-headed, 3 are not bald-headed, and part 4, at least 2 are bald-headed. So the first case is to come up with a tree diagram to be able to show the probability space. The first one can be bald or not bald, and second one can be bald or not bald, bald, not bald, third one, bald or not bald, bald or not bald, bald or not bald, bald or not bald. So the fourth one can be bald, not bald, 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 lastly bald or not bald. So these are the outcome, these are the probability space that you can have for this particular instant. So there are quite a number of them, and they're going to help us to answer the question. So part A, we are required to get the probability of 2 are bald-headed. So probability of 2 are bald-headed. So in this case, we need where we have only 2 bald-headed, and there are about 4 of them. You can see the first case here is when you have the bowed, bowed, and not bowed, that one. Then we have the other case, bowed, not bowed, bowed, not bowed, that one. And then we have bowed, not bowed, not bowed, and then bowed, just near that one. Not bowed, 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 not bowed. That's the fourth one. The fifth one should be not bowed, not bowed, bowed, bowed. That is the probability of bowed, bowed, not bowed, not bowed, or probability bowed, not bowed, bowed, not bowed, or probability bowed, not bowed, not bowed, bowed, or probability not bowed, 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 not bowed, or probability not bowed, bowed, not bowed, bowed, and lastly probability of not bowed, not bowed, bowed, bowed. 6 of them as I have listed here with black. So getting the probability of this one is quite very nice because all of them are similar, so you're not going to hassle a lot on the same. So you're going to have the probability of bowed, bowed, not bowed, not bowed. So this is going to be bowed is 15%, so that is the same as 0.15, then times 0.15 times not bowed 0.85 times 0.85. So you're going to find that in the 6th instance you all have the combination just changing, but it's the same because we have 2 bowed and 2 unbowed. So we are not going to list all of them here because it's just a mere repetition. We just multiply this by 6 outcome, and that one is going to give us 0.0975 if we give to 4 decimal places. So that is the probability of having 2 bowed headed. So for part B, we are required to get less than 3 are bowed headed. So in this case, less than 3 means can either have 0 bowed headed, 1 bowed headed, or even 2 bowed headed. So you need either 0, 1, or 2 bowed headed. So in this case, we are going to we already have the 2 bowed headed, so you are going to add the 0 and 1 to be able to conclude that. For 0 bowed headed is where we have B prime, B prime, B prime. So there you go for 0 bowed headed. And then for 1 bowed headed, we have quite a number of them. The first one is bowed headed, and the others not bowed headed. There you go. And then the other one is not bowed headed, and the others are not. And this is going to be this case here. Then the third one is not bowed-headed. There you go. Not bowed-headed, but bowed-headed, and then not bowed-headed. So there you go. And then last three we have the not bowed-headed, not bowed-headed, not bowed-headed, and then bowed-headed. So there. So those are the one with X there is for one bowed-headed, and then the last one there is where you have no zero bowed-headed. So we are going to add that one for the two bowed-headed which we already have here in part A as 0.0975. So probability of less than 3, this one is probability of 0 bowed, 1 bowed, or 2 bowed. So for the 0 bowed, this is going to be B prime, B prime, B prime, B prime. Then we add a bit of 1 bowed. We have 4 outcome. We have B, then B prime, B prime, B prime, or B prime, B, B prime, B prime. And one is B prime, B prime, B, B prime, and the fourth one is B prime, B prime, B prime, B. And then those are the 1 bowed. Then 2 bowed, you already have it as 0.0975. So we just add these ones, and for the first case, the B prime, B prime, B prime, B prime, that is 0.85 times 0.85 times 0.85 times 0.85. That is not bowed. Then we add the 4 keys of the 1 bowed. They are going to be similar in a way. We only have 1 B in the 4 scenarios and the 3 B prime. So just go to this one of them. For B is 0.15. Then you multiply by B prime 0.85 times 0.85 times 0.85. All of them we multiply by 4, so that to get the 4 scenarios. Then we add the 2 bowed. So that is for the 1 bowed. For 2 bowed we already have in part A as 0.0975. So this one is going to give us, for the first case here, 0.85 times 0.85 times 0.85 times 0.85 is going to give us 0.5220 if we work with 4 decimal places. This one we add for the 1 bowed, the 0.15 times 0.85 times 0.85 times 0.85, then you multiply by 4 of them. This is going to give us 0.3685 if we work with the 4 decimal places. And then for the 1 bowed, for the 2 bowed we already have is 0.0975. So when we add the 3, we are going to have as 0.9880. So let's look at part C. 3 are not bowed-headed. 3 are not bowed-headed. So in other words, we need one bowed-headed. And the good thing is that in our part B, we already have that case. So for one bowed-headed, we have this one. So 3 are not bowed-headed. This means probability 3 not bowed is the same as probability of only one bowed-headed. And just as we have shown there, so it's going to be this figure here, 0.3685. Now to our last question, that is part D. At least 2 are bowed-headed. It means either 2 are bowed-headed, 3 are bowed-headed, or 4 are bowed-headed. So in other words, this one we can look at it in the other way around, the same as just having at least 2. It is not having one bowed-headed or none bowed-headed. That is another way of looking at it. So part D, we need to have at least 2 bowed-headed. So it is 2, 3, or 4. So at least 2. So this one is probability of 2, 3, or 4 bowed. So this one is the same as 1 minus probability of 1 bowed or 0 bowed. So can either have it like this one. So let's have 1 minus probability of 1 bowed. So we already have that one from our part C. The figure is just here with us, 0.3685. That is for 1 bowed. Then we add the 0 bowed. 0 bowed, we already had it in our B, 0.522. 1 minus, when we add these 2, we are going to get as 0.8905. So 1 and 1 subtract 0.8905, we are going to get as 0.1095. So to our question number 4, we have the probability that the dart players Akinyi, Kamau, and Juma hit bullseye are 0.2, 0.3, and 0.15 respectively. So if each play once, show the possible outcome on a tree diagram. Then part B, calculate the probability that all hit the bullseyes, part 2. Only one hit the bullseyes, part 3. Almost one misses the bullseye, and part 4, only Kamau hits the bullseye. The first question we need to answer, part A, is to show the possible outcome on a tree diagram. So we are told that they are good to play once. So we can start with either, can go in the order that they have been written, or either any order, as long as they are just playing once. If we start with Akinyi, in the first case, Akinyi can hit the bullseye or misses. So we can have missing for A prime. Then we can have Kamau can hit the bullseye or can even miss. If Akinyi had missed, we can have Kamau hitting or missing. Then the third case is for Juma, can hit or fail. Juma or failing, Juma hitting, Juma not hitting, and then can have it like that. So these are the possible outcome. We can have Akinyi, Kamau, and Juma, all of them hitting. Can have AK, J prime, that is Akinyi, Kamau, and then Juma missing. Then you can have this one, AK prime, J, and then you can have AK prime, J prime. In this case, we are going to have A prime, KJ, and have A prime, KJ prime. In this case, we have A prime, KJ, and then so this is A prime, K prime, and then last we can have A prime, K prime, J prime. So those are the possible outcome, and we require to answer the question. And maybe before we answer the question, we need to write their probabilities so that you can have an easy way of answering. So Kamau, we start with Akinyi. Hitting the bullseye is 0.2, so you can have that one as 0.2. So missing should be 0.8 because the two of them should add up to 1. Then Akinyi, the Kamau now, hitting the bullseye is 0.3. And then failing to hit should be 0.7, so that the two add up to 1. Then Kamau, then John, Juma, hitting is 0.15. Then not hitting should be 0.85. 0.15, 0.85, 0.15, 0.85, 0.15, 0.85. But BA1, we are required to answer all hit the bull's eye. So probability all hit the bull eye should be probability of A, K, and J. So this is where all of them are hitting the bull eyes. So this is going to be 0.2 multiplied by 0.3 multiplied by 0.15, and this is going to give us 0.009. 0.009. So part 2 of B, only one hit the bull's eye. Only one hit the bull's eyes. So for only one hit the bull eye, we are going to have either Akinyi hitting the bull eye, the other one misses. That is that scenario. Then we can have the other case is Akinyi miss, the Kamau is the one who is only one hits the bull. So this is that case. So only Kamau hit, the others misses, and then the last one is only Juma is going to hit the bull eye, and that is the scenario. So we have those three options to be able to answer only one hit the bull's eyes. We have probability of AKJ, those are prime, or probability of AKJ, A and J missing, and then all probability of AKJ. Now only Juma is going to hit. So this is going to be given by 0.2 2 times 0.7 times 0.85, we add 0.8 times 0.3 times 0.85, we add, for the last one, 0.8 times 0.7 times 0.15. So when we add the 3 and multiply them, the first one is going to give you 0.119. The second one, that is 0.8 times 0.3 times 0.85, should give you 0.204, plus this last one, 0.8 times 0.7 times 0.15, should give you 0.084. So 0.119 plus 0.204 plus 0.084, this one gives us is 407. So part 3 says that almost one misses the bull eye. Almost one misses the bull eye. So in this case, we just need one missing the bull eye. Either Juma missing, or Kamau missing, or the Akinyi missing the bull's eye. Juma missing, that is the first one. The other one is Kamau missing, it is there. And then the last one is now the Akinyi missing. So there you go. So probability of one misses. So we have 3, have A, K, J prime, or have A, K, J, no K prime there, or A prime, J, K. So this is going to be 0.2 multiplied by 0.3 multiplied by 0.85, we add 0.2 times 0.7 times 0.15, we add the last one, A prime is 0.8 multiplied by 0.3 multiplied by 0.15. So this is going to have the first one, you're going to get 0.051. We add the second one is 0.021. We add the third one is 0.036. So when we add the 3, it should give us 0.108. So part 4 of the question, we need probability of one Kamau hitting. So that is A prime, K, then J prime. So this is going to be given as 0.8 times 0.3 times 0.85. And when we multiply the 3, it should give us 0.204. Thank you very much for your time.